Guys, welcome to my channel. Just imagine how chocolate fountain will cover the sweet bun and how it is beautifully covered and how the taste of the our sweet bun. So just before going to our topic, and our topic is surface coating and or protective coatings. This is the fifth video on corrosion. You can see all my previous videos which is explaining the all what is corrosion, types of corrosion, theories of corrosion and factors affecting corrosion, which will help you to understand this session very effectively. The link is provided in the description. You can see and follow it. So we know when metal involved in corrosion. So if you keep a metal in the atmosphere, the atmospheric gases or moistures come into contact with the metal, and then the metal involved in corrosion by making metal oxides or metal carbonates depending on the atmospheric gases or moistures. Okay, so this is the one point. And next thing is, if you keep a metal in the vacuum, what will happen? So if you observe for a long time also, the metal doesn't involve in corrosion. Why? Because in the vacuum there is no atmosphere. To contact with metal there is no gases or moistures. To whom metal involved in corrosion is nothing but oxidation means losing of electron. The loosed electrons will not shared by anyone. That's why corrosion, the oxidation will not occur separately. That's why corrosion doesn't occur when you keep a metal in the vacuum. But it is impossible to keep a working metal in the vacuum. Why? Because we need to work with that metal, so we cannot work on the vacuum. That's why keeping vacuum is not good idea to protect metal. Why? Because we need to work in the atmosphere only. So that is the one thing. But basic thing is, when you avoid the metal contract with the atmosphere, when you avoid the interaction between metal and atmosphere, you can protect metal from the corrosion. So if you observe the molybdenum metal, when it is kept in the oxygen atmosphere, it forms a molybdenum oxide. This molybdenum oxide is a very volatile one. Immediately this molybdenum oxide volatiles and evaporates into atmosphere, and it makes a fresh layer on the molybdenum. Again this layer involved in corrosion, it will be evaporated, next layer and next layer, like the total metal destroyed and total metal involved in corrosion. So, but if you observe the aluminum forms a protective layer, aluminum oxide. This is a very stable one. It will cover the material. Now, inside aluminum material is the aluminum metal is there. Outside in the surface, aluminum oxide layer is there. This layer is a very stable one. It protects the base metal from the corrosion by making a continuous layer on the surface of the aluminum. Like that, we get an idea. For example, molybdenum metal is there. Intensively we can make a aluminum oxide layer on the surface of molybdenum. Why? Because molybdenum also forms metal oxide, but it is a volatile nature. To avoid that one, we only doing a intensively we are making aluminum oxide layer on the molybdenum. Aluminum oxide is a very stable one. It will protect the molybdenum. So how it is protecting this aluminum oxide layer? Disconnect the interaction between the atmospheric gases and molybdenum. So here molybdenum is there is no interaction between molybdenum and oxygen. Why? Because there is an interface, aluminum oxide is there. So aluminum oxide disconnecting the connection between the molybdenum and oxygen. By this we can protect the metals. This technique is called surface coating or protective coating. The basic principle in this process is the contact between base metal and the corrosive atmosphere, it should be cut off. The interaction between base metal and corrosive environment should be cut off. Then there is no oxidation, there is no corrosion. This can be done by forming a continuous layer with the coat metal on the surface of base metal. I will explain what is coat metal and what is base metal. If you make a continuous layer on the base metal with coat metal, you can protect base metal from the corrosion. Such a coating referred as surface coating or protective protective coating. We have a different methods to make a surface coating. One of the advanced technique is so spraying of nanoparticles on the surface coating. So nanoparticles, these are the nanoparticles. This is the base metal, and this is the base metal. We should be protected this metal. So when you spray the nanoparticles, it forms a continuous layer on the surface of metal. So this is the called coat metal, and which metal we have to protect is called base metal, by whom we make a surface is called coat metal. So there is a two types of protective coatings can be available. So for example, if you take a iron metal, so iron metal in the galvanic series, before iron metal having higher oxidation potential values having metals, and after iron having lower oxidation potential metals. For example, we can see here, so zinc, magnesium, lead, these are the higher oxidation potential than the iron. They act as a anodes compared to the iron. So if you observe the tin, copper, silver or Ag, they are acting as a cathodic metal compared to the iron. So in zinc iron, zinc act as a anode and iron act as a cathode. In copper tin, zinc iron act as a anode and tin act as a cathode. So you can make two protective layers in different protective layers over the iron surface. So one is having higher oxidation potential metal can coat on the iron surface. This is called sacrificial coating or anodic coating. If you can make a protective layer with lower oxidation potential metals like tin or silver or Au or copper, it is called noble coating process. We will explain why it termed as sacrificial coating, why it is termed as noble coating. The first type of coating is anodic coating. It is also called sacrificial anodic method. Let's see, oxidation potential of zinc is greater than the iron, so zinc act as anode here and then the iron. So when you make a coating with higher oxidation potential metal on the surface of iron, so now zinc act as anode and iron act as cathode. If you remember the sacrificial anodic cathodic production in the previous session, here also we just connect a higher active metal than the iron by external wire. Both are same concept. Here coating will happen, here connection is happen. So only difference is connection and coating. If you make a continuous surface layer, it is called coating. If you just connect with external wire, it is called cathodic protection. So both differences are, concept is same, but way of protection is different. Here connection is there, here surface continuous layer we formed and make it as a protective layer, and we protect the iron metal from corrosion. Okay, so when you make a zinc coating on the iron metal, when you are using that object, some damage will happen on the surface of the iron. So now iron is exposing to the air. So who involved in corrosion, iron or zinc? Why? Because see here always iron act as a cathode with respect to zinc. Zinc act as a anode. So there is a two different metals, different spots is there, anodic spot and cathodic spot, and atmospheric gases or moisture is there. So who involved in corrosion? Always anode only involved in corrosion. Even though damage will happen, only zinc involved in corrosion. Until unless the total usage of zinc, iron never involved in corrosion. So up to total destruction of zinc, then iron involved in corrosion. That's why here zinc sacrificing itself to protect iron material. That's why it is called sacrificial coating. So it is also called galvanic corrosion, galvanic coating also. So you can zinc coated on the iron metal, zinc coated on the copper metal, iron coated on the copper metal, copper coated on the silver metal. All are the example for the anodic coatings. Okay, so second one is cathodic coating or noble coating. So you can see here iron oxidation potential is greater than the tin. That means iron act as anode here, and tin act as cathode here. When you make a surface coating with a cathodic material on the anodic material, so iron is a anode here and tin is a cathode here. So surface coating with cathodic material is called noble coating. So if any damage will happen, now iron is exposing to the air, right? So we involved in corrosion here, anode and cathode is there, always anode involved corrosion. So our base metal involved in corrosion. So this is very important thing when you make a continuous layer with a tin. So continuous layer is there, no damage is there, this metal is very good idea. Why? Because iron doesn't involve in corrosion, because of it is protected by the tin layer. Tin also not involved in corrosion. Why? Because it having lower oxidation potential, it is not interested to involve in oxidation process. That's why both doesn't involve in corrosion. But problem is there, if any scratches will happen like this, any scratches is happen, so now our base metal involved in corrosion, so that is serious issue, it leads to fitting corrosion. So we need to more care and more maintenance when you make a noble coating on the base metal. So then how to coat a metal on other metal? We also paint the metals to protect the corrosion, protect the metal from the corrosion. Yes, painting also a protective layer. It is also a surface coating only. But with organic component, paint is an organic component. It is in liquid form. We can easily spread out on the surface of the metal. But my question is, I want to coat with metal on other metal surface. Metals are solids. Okay. So how can I coat a solid metal on another solid metal? Okay. So going to next slide, just remember base metal mean on which coating occurs. So here iron metal is base. Here this metal is called base metal. So on which we are going to coat with some other. Okay, this is base metal by whom we are making coating, that is called coat metal. These two things are very important. So frequently these will come in the next slide. One of the method of surface coating is hot dipping. Just consider here chocolate fountain. So when chocolate is melted and it become as a liquid and it is continuously moving on the fountain. So when you keep a sweet bun over there, the chocolate make a surface layer on the sweet bun, and when you keep it out it will become dry and it will looking attractive and very tasty. The same principle apply here. So it just let's consider this chocolate fountain is called coat metal. This chocolate fountain is a coat metal and our bun is a base metal. So you are making coat metal coating on the base metal. Okay, just think about it. Hot dipping of base metal into molten bath of the coat metal. So we already known what is base metal, what is coat metal. You need to make molten bath of coat metal. It means liquid form of coat metal. It is a metal. When you heat that metal up to its melting point, it become liquid. That is called molten bath. In that molten bath you need to dip base metal. That's why it is called dipping method. And hot mean it is a molten bath. That's why hot dipping method. So then it's make a protective layer on the base metal and it is called hot dipping. The only condition in this process, always coat metal melting point should be lesser than the base metal. Coat metal melting point should be lesser than the base metal. You are dipping base metal into coat metal. Because yes, if the base metal melting point is lower than the coat metal, so base metal and cold metal both will dissolve and they make it as a alloy. But here we are not going to prepare alloys. We just want to make a surface coating with coat metal on the base metal. So this is the condition. Coat metal melting point always should be lesser than the base metal. That means always base metal having high boiling point. Base metal should be having high melting point. So there is a one question, base metal A having 200 degrees centigrade melting point. So coat metal B should have which is the ideal melting point of B. So if it is 300 degrees centigrade, so base metal having already A metal having 200 degrees centigrade. If your coat metal having 300 degrees centigrade, both will melt and make it alloy. This is not our idea. So 250 it is greater than 200, this is also not good idea. So 200, even if you apply 200 also, base metal become liquid, this is also not we desired thing. But a coat metal having 150 degree centigrade only, that means only coat metal involved in liquid form, involved in melting process, only coat metal in liquid state, our base metal having 200 melting point. That's why the base metal should not become liquid, it's still like as a solid. Now solid is going to dip into liquid coat metal, that coat metal make it as a surface layer over the base metal. When you keep it up outside, that base metal will be covered by the solid layer of the coat metal. So this is the hot dipping method. So you can coat with base metal with zinc or tin. If you coat the zinc, it is called galvanizing. If you coat with the tin, it is called tinning. Okay. So first method, galvanizing. How can we coat zinc over the different materials? For example, iron material. If you make a coating with zinc metal, it is called galvanizing. So just see here, iron melting point is 1538 degrees centigrade. So definitely zinc melting point should be lesser than the iron, and its melting point is 449 degrees centigrade. Okay. So now the process of dipping base metal into molten zinc. So zinc is the coat metal here. So if the zinc is coat metal, the process is called galvanizing. Okay. So zinc melting point maintained at the 449 degrees centigrade. So very simple process here. So first take it as a your iron metal, base metal you are taking here, and just uh, keep into the dilute H2SO4, then any rust, already formed rust, everything will be dissolved in H2SO4. And next, that was moving towards the water, you can wash the any adsorbed H2SO4 over the surface. Then you can make it as a dry by passing into drying room, then all moisture and everything will be cleaned up on the surface of metal. Now that base metal is dipped into hot molten bath of the zinc. So this is the liquid state, it is maintained at the 450 degrees centigrade, or around 450 degrees centigrade, or 449 degrees centigrade. So it is in liquid form. But iron metal melting point is 1500, over 1500 degrees centigrade. That's why iron will not become liquid, only hot zinc only covered over the iron rod, and that iron rod is taken out and moved through the rollers. If extra zinc is formed over the iron, it will be taken out and extract the extra zinc here, and it make it in the hot, it making dry by you by passing into heating room, and and subsequently into cooling room. Finally we get a galvanized sheet. That means iron is covered by the zinc. If you make it a zinc, it is called galvanized. Okay, this is the process, very simple process. So but you can see here, over the zinc, hot zinc liquid, we make it a ammonium chloride layer. What is the necessary of this ammonium chloride layer? See here, zinc is having higher oxidation potential metal, and is already at 449 degrees centigrade. In factors affecting corrosion, we learned one thing: high temperatures increases the rate of corrosion. So zinc having naturally oxidation potential, and it is high oxidation potential metal, it is act as anode. It is also at high temperatures, it immediately interact with the atmospheric gases and involved in corrosion. To avoid that thing, we are making here NH4Cl cover over the zinc metal. So this is the galvanizing process. So next process is hot dipping of by tinning. So here tinning means the process of dipping base metal into the molten tin. That means instead of zinc we are using tin as a coat metal. So, okay, so this is called tinning. That means coat metal is tin. Okay, so iron melting point is 1538 degrees centigrade, tin melting point is 321.9 degrees centigrade, 321.9 degrees centigrade. So we should maintain 322 degrees centigrade to convert tin into liquid form. Here I am wrongly mentioned here, 322 degrees centigrade we need to keep. So then tin will become liquid state. So iron having 1538 degrees centigrade, we don't have any problem to become alloy. So only surface coating will happen. Why? Because melting point of iron is greater than the tin, so there is no issues with that one. So as like galvanizing, initial cleaning process same. Instead of dipping into zinc, we are dipping the base metal into molten state of tin. That is the same. Both are same, only the molten bars are only different and their melting temperatures are also different. Those two things are different from the tinning and galvanizing. But here, if you observe here, before passing to molten bath of tin, we need to pass over the zinc chloride. We need to pass over the zinc chloride, our base metal. What is the necessary of this one? Zinc chloride. So see here, if you make it, this is the iron metal. Okay, this is iron metal. If you make a coating with tin metal, if you make a coating with tin metal, so this is the tin metal coating. If any breakage will happen here, now iron is exposed to air and it leads to fitting corrosion. Okay, if you make a in between, if you make a zinc chloride layer here, if you make a zinc chloride layer here, so if any breakage will happen, this zinc chloride protect the base metal. So for that purpose, to get some time to observe the breakage, we need some assistance. That assistance can be done by this zinc chloride. So that's why we need to pass over the zinc chloride before pass over the tin. So and final process same, just like galvanizing. Okay, so what are the differences between galvanizing and tinning? First difference is coat metal. If the coat metal is zinc, it is called galvanizing. If the coat metal is tin, it is called tinning. Okay, so zinc is a anode compared corresponding to the iron. If you take iron, zinc is a anode. That's why it is called anodic coating or sacrificial anodic coating. Tin is a cathode comparatively iron. That's why the tinning is a cathodic coating or noble coating. Okay, if any crack will happen in galvanizing no problem, zinc only involved in corrosion. That's why it is called sacrificial anodic production. If any crack will happen in tinning, so tin metal doesn't involve in cracking, in base metal involved in corrosion. That's why it is dangerous. And other thing is food containers. So to store food, galvanizing metals are not suitable. Why? Because they are coated with the zincs. For example, iron metal is there. This iron metal is coated by the zinc metal. So that means inner side another zinc layer is there. If you keep some pickles or some many things, some pickles having acidic nature, H plus ions is there. In presence of H plus ions, the zinc involved in corrosion. So we already known wet corrosion in presence of acidic medium, it releases H2 gas and zinc in dissolved as a Zn plus 2. That means Zn plus 2 come into your food items, you will consume that thing, you will be become illness, it leads to illness. That's why galvanizing metals are not suggested to store the food materials. But tin is a noble metal. If you make a coating with this is the iron metal and you make a coat surface, if you make a coating with tin metal, tin is a noble metal, doesn't involve in corrosion, so it will not dissolve into your food items, so it will not create any problem. So tinning is best way to store food items. So these are the important and differences between galvanizing. This is the topic for today. So how we can make a protective layer, what is surface coating, what is the types of surface coating, and how can you make surface coating, the process hard dipping. In that hard dipping there is a two methods, galvanizing and tinning, the process and differences we learned here. So if you like my video, please share it and comment it. Thank you for watching.